Alright, PreCalc, here we are with 12.3, Day 2, the tangent line problem continued. Alright, Day 2 should be starting somewhere around example 4 here, and we are trying to find the slope of negative 3x plus 5 using the limit process. Now, negative 3x plus 5 is a line, so we should know the slope is negative 3. But we're going to go through the limit process and just show our work with that to practice. Okay, we have been doing the limit process by putting in an actual number previously. Okay, like we had been doing the limits, and we put in like negative 2 for x. So we would have f of negative 2 plus h minus f of negative 2. And that's good, and that works, and that'll get you the instantaneous slope at negative 2, but that doesn't help us going forward. Okay, what we can do is just use x, leave the x in there, and then we'll have a slope formula to use anywhere. Okay? So we're not going to put any particular x value in for x. So we're looking at the limit as x goes to 0, h goes to 0, of f of x plus h minus f of x over h. So we have f of x plus h, so we're putting x plus h in here. For the x next to negative 3. We maybe go over here and do the scratch work on the side. F of x plus h would equal negative 3 times x plus h so f of x plus h should be negative 3x minus 3h plus 5. Limit as h goes to 0 of negative 3x minus 3h plus 5 minus the original f of x all over h. Okay, if we distribute this minus sign, that'll be a minus, that's going to be a plus 3x and a minus 5. So the minus 3x and the plus 3x would cancel. Plus 5 minus 5 cancels. Limit as h goes to 0 of, we have negative 3h over h. Our h's cancel. And we're left with the limit as h goes to 0 of negative 3. There is no h left. So that h doesn't affect it at all. Our answer is just negative 3. Which we knew would be the slope because it's a line. And it's negative 3x. We know the slope is negative 3. Okay? Let's say it was something else. Let's say it was like an x squared, and the h's would reduce, and one of them goes to 0, and you're going to have like negative 3x plus 2 or something. Now that is the slope formula to use anywhere on that equation, and you can find the slope anywhere, as opposed to the other way, which is just going to give you the slope at that one spot. If you leave the x in and don't put a value in for x during the limit process, then you'll have the formula for the slope, and then you can use that. If the question is going to be just like a one-time question, it can be helpful to put the number in. To put that number in. If it's going to be a multi-step question where you're going to have to answer multiple problems for the same function, it might be helpful to have the formula and leave the x in there. Okay? Find the formula for the slope of the graph x squared minus 2, and then find what are the slopes at this point and this point. So we have a multi-part problem here We're trying to find two different slopes. Okay, it's not a line, so the slope does change as you go along. So it is helpful to have the formula, and that's why they're asking for that in this one. Okay, so let's have limit as h goes to 0, f of x plus h minus f of x over h. If you want to do a little scratch work on the side to figure out what f of x plus h will be, we'll have x plus h squared minus 2. Hopefully we're in PreCalc, we can square a binomial. We're going to have the first one squared. We're going to have the last one squared. Multiply those two together and double it for the middle. X times h times 2 plus 2xh. So that is f of x plus h. Back over here. Limit as h goes to 0. We're going to bring that in for the f of x plus h. Minus the original, x squared minus 2. Okay. I find it helpful to just kind of do this at the same step here. Don't do a whole nother step. Save some writing. And it's also nice if you have another color handy. So we have the x squared minus x squared minus 2 plus 2. Two xh plus h squared over h. Okay, we can use this h. They both have an h, so if you want to, we could take an h out in front. 2x plus h. And those h's cancel. And then we just have the 2x plus 0 or just 2x. That's our slope formula. To find the slope anywhere on the graph of x squared minus 2. So if you want to know the slope at -3, 7, okay, 2 times -3 equals -6. What about at 1, -1? It's 2 times the x, so 2 times 1, our slope there is 2. So if you have x squared minus 2, okay, not perfectly, I mean, it's a sketch, but at 1, -1, okay, we're definitely positive, and we're not very steep. Our slope there is 2. At -3, 7, yeah, we're getting pretty steep there. It's going to be pretty steep, and you read slope left to right, so yes, it's going to be coming down pretty steep, -6. You started with the function x squared minus 2 and used the limit process to derive another function, m equals 2x, that represents the slope. The derived function is then called the derivative of f at x. It is denoted by f prime of x, which is read f prime of x. That's why I said it that way. The derivative of f at x is given by the limit process with the difference quotients that we've been doing. Remember that the derivative f of prime of x is a formula for the slope of the tangent line to the graph of f at any point x, comma, f of x. Just trying to see how we're doing on time. We're doing okay. Now we're going to do two rather tough examples, and then you're going to get the shortcuts, and it's going to make life easy. And you're going to probably hate me for making you go through some of the long ones, because it really, really is not too terribly difficult. That we could look at this, and I already know what the slope's going to be. The slope formula without, obviously I have the answer key next to me, but without that, it's like, boom, got it. This one's a little bit more difficult. But this, if it's just like regular exponents and powers, you should be able to look at that and know it pretty instantaneously. Here we go. F prime of x equals the limit as h goes to 0. F of x plus h minus f of x over h. Okay, a little scratch work over here on the side to find what f of x plus h is. Alright, use our binomial squaring. We got x squared plus 2xh plus h squared. And I don't think we can combine any of that, so that's fun. Limit as h goes to 0 of all that minus the original f of x So that's honestly the worst part, is figuring this out, putting it here, and then writing all this down. Because after we distribute this, we should get a lot of things that cancel, and things that factor out and cancel that h. So we have a plus 2x to cancel this minus 2x, minus 3x squared to cancel out the plus 3x squared. We're going to use our brains here and do two things at once. So those are gone, and we're going to rewrite, simplified, but we're also noticing that it's 6xh, 3h squared, minus 2h. We're going to pull an h out in front of all of those. So we're just going to take the h out in front right now. 6x plus 3h minus 2. Those h's cancel. The h we pulled out in front cancels with the denominator. Okay, the limit as h goes to 0 of 6x plus 3h minus 2. So if h goes to 0, 3 times 0 is 0, and we're left with just 6x minus 2 for our derivative f prime of x. Okay, now knowing that it's 6x minus 2, how do you suppose I could look at that, boom, and tell you it was 6x minus 2? How does this quickly turn into 6x minus 2? Think about that. Alright? Next, square root. Alright, this is not going to be pretty, but we'll do our best. We'll do our best. F prime, and for the original function, square root of x plus 1. Notice that the plus 1 is outside the square root, not inside the square root. Oh, we missed our part 2 up here. use the derivative to find any points where the tangent line is horizontal. Tangent line horizontal would mean the slope is 0. So we're going to set 6x minus 2 equal to 0. So we'll have 1/3, and we'll plug that back in, and we should get like negative 1/3. Onward to this one. Alright, f prime of x equals, I know you guys are losing your patience here. Okay, and our f of x plus h is actually pretty easy to do because there's nothing going on. It's just x plus h is going in the radical. So we're going to have the square root of x plus h plus 1 minus square root of x plus 1 over h. So I have a minus square root of x and a minus 1. The plus 1 and the minus 1 cancel out. Okay. Now, the fun part. Because we have an h inside this. Alright, that's a little bit complicated, but we also have an h still down here. And in the past, all of our previous examples, we've been able to get an h to factor out of the top to cancel with the one on the bottom, so we don't have to divide by 0. So how are we going to do that this time? Okay, usually we try to make sure the bottom's nice and the top is okay to be crazy. This time, because we're trying to get an h out in front, we're going to let the bottom be crazy and we're going to make the top be nice. We're going to use the rationalizing technique we discussed earlier, where we've used the rationalizing technique in the past to clean up denominators. This time we're going to use it to kind of help out with the numerator. So it's the same exact stuff, but with a minus in the middle, or opposite signs. So if this was a minus, we would have used a plus. Alright, when we do this one times this one, we'll get that squared. So we'll just get x plus h on the top. When we do this one times this one, it's going to be a little bit ugly, and it's a minus. And then when we come back and do this one, it's that same ugly one, but it's a plus, so those would cancel. Right, so we do radical x plus h times radical x plus h gives me regular x plus h. And then we would have a minus, I'll just write it out. It's going to be long and messy, but we'll write it out just so you can see. Minus radical x plus h. And then the very next step is this plus 1. Which means those would cancel. And then now we have a radical x times a radical x, positive, negative, so it's going to be a minus x over h times square root of x plus h minus square root of x. So those canceled. Then we have this minus x and plus x canceling. The limit as h goes to 0 of, we just have h on top, over h times we got flip-flopped. So that was a minus, and we're going to multiply by a plus. Still results in the same thing. Those would still cancel out, but just this is a plus. Plus. You guys are smart enough, you probably caught that. I changed that from a minus to a plus there. Okay, so now these h's cancel, and when I do the limit as x goes to 0, or h goes to 0, we're going to have the square root of x plus the square root of x, or 1 over 2 square roots of x. That's going to be your derivative or slope formula. Notice they gave us nice points to test it out at 4 and 9, perfect squares. So at 4, 3, 2 times the square root of 4 is 2. Our slope there is 1 over 4. Square root of 4 would have been 2. 2 times 2 is 4. At 9, 4, 1 over 2 times the square root of 9. 3 times 2, we got 1 over 6. Okay, now for the not nice part. You're going to, well, it is the nice part, but you're not going to be happy. The shortcuts. The shortcuts. Derivative shortcuts. If f of x equals c, then the slope is 0. Okay, what's the slope of a constant? F of x equals c, like f of x, or y equals 5. It's a flat line. No slope. 0. If f of x equals ax plus b, it's a line, and it's not 0, it's not a flat line, then we actually have slope. It is just a. Right? Y equals 3x plus 5. Our slope would have been 3. So far, pretty common sense stuff. Here's the good one. The power rule. The power rule. Okay? Ax squared plus bx plus c. This is pretty similar to the one that I told you I could look at and get it pretty instantly, and now you'll be able to do it too. Okay? Whatever the power is, it comes down in front, and you drop this one a power. So if it was 2, now this is to the first. If it was to the first, now it's just gone. It's to the 0 power. And if it didn't have an x with it, it's gone. So, like, I think what was our example before? 3x squared minus 2x. So I bring the 2 down in front. 2 times 3 is 6x to the first minus 2. Boom. That's how we got that one so quick last time. Okay, so any power rule for any exponent when you have, the exponent comes down in front, and then you have one less. Alright? Rapid fire. Ready, set, go. F of x equals 4. It's a flat line. The slope is 0. F of x equals 5x plus 10. It's a line with a slope of 5. So you could use that just slope, like brain power there, like previous knowledge of what slope means. Or we could use these up here. It's going to be 5. Here's a good one. Think about that real quick. The 2 comes down in front. We'll have negative 6x. This x drops, x to the 0, and this goes away. You got to use your brain power here. 1 over x is x to the negative 1. So this is going to come down in front. Now, what's 1 less than negative 1? Negative 2. How do you rewrite negative exponents? Underneath. Negative 1 over x squared. Another tricky one. Square root is like the half power. So bring the half down in front. What's a half minus 1? negative half. Okay? What happens with negatives? It goes underneath. And now we're back to 1 over 2 times the square root of x on the bottom. Alright, kids, fun stuff. Sorry that one got a little long, 25 minutes. It could be shorter depending on how far we got in class the day before. Now you have the power of derivatives. Good luck.